Hey everyone! Today we're going to be solving the equilibrium temperature of mixing two substances at different temperatures. Or as I like to call it, dropping a hot iron nail into a glass of water. So to get us started, we have a 2 gram iron nail, and it's going to be at 300 degrees Celsius. And we have 150 mils of water, and it's going to be at 20 degrees Celsius. And in this question, we're going to have our little glass of water, and we're going to have our hot nail, and we're going to drop it in. Plunk. And the question is, what temperature do they become at equilibrium at? So when will the water stop heating up, and when will the nail stop cooling down? And in order to solve this, you need to know that the energy change will be equal, but opposite. So as the nail loses energy, because it's cooling down, the water will gain an equal amount of energy and warm up. And we can write this out by saying our water and our iron, and the energy of the water must equal the negative energy of the iron. And that's how we get this started. So let's fill in our equation. I'm just going to move this up here. We got our water and our iron. And we actually use the equation Q equals mc delta T. So we end up with mc delta T of the water is going to equal the negative mc delta T of the iron. And my students often ask me, what if I mess up which side the negative goes on? What if I make the water negative? Great news, everybody! It doesn't matter. If you had made the water the negative Q and the iron the positive Q, you are still going to get the exact same answer. So don't panic about that, as long as one side is a positive heat energy and one side is a negative heat energy, you will get the correct answer. Because we're solving for temperature final, not delta T, we're going to have to expand this out and write the delta T as mc temperature final minus temperature initial, and this side's the water, is equal to the negative of mc temperature final minus temperature initial. And this side is the iron. And the only thing that is common between these that we need to find is this temperature final. So let's start off by filling in all of the things that we know. We know the mass of the water, that was provided. It's 150 grams. We know that it's 150 grams because for every mil of water, that's 1 gram. 150 mils, 150 grams. The specific heat capacity, the C value, of liquid water is 4.184. You're going to need to find that value in a specific heat capacity table, either in your book or online. But it's never provided in the question, or seldom is. You're going to need to find that. The temperature final, we don't know. Subtract the temperature initial of the water, that's 20. Water side, complete. The iron side, it's the negative of the mass of our iron, that's a 2. C is the specific heat capacity of the iron. We need to look that up in a table. Once you find that in a table, you're going to find that it's 0.444. The temperature final is unknown, but the temperature initial of the iron was 300. If you've gotten this far, you've done all of the chemistry. The only thing that's left now is some algebra. Hooray! So I'm going to show my steps as we finish off getting temperature final here. I'm going to multiply these numbers in front. It's going to leave us with 627.6 temperature final minus 20 will equal negative 0.888 temperature final minus 300. I need to get these temperature finals all by themselves, so we're going to make a little mess first, and then it'll clean up, I promise you. So let's multiply these coefficients into the brackets. 627.6 temperature final. Multiply it now to the negative 20. It's going to equal negative 12,552. which will then equal, we do the same thing on this side. Multiply that negative 0.888 in, negative 0.888 temperature final. Mind that it's a negative times a negative here. It actually becomes a positive 266.4. We are almost there. We're going to bring our temperature finals to the left, and I'm going to bring the term here that doesn't attach to a variable to the right by adding to both sides. So I add a 0.888 temperature final to both sides, and we're going to add 12,552 to both sides. I'm just showing this in case you're watching this and wondering what type of math I'm doing here. I'm going to scroll this up. We are almost done here. To finish this off, it leaves us with 628.488 temperature final. That's what we get when we combine those terms. Equals 12,818.4. To get our temperature final, we divide both sides by the 628.488. We're almost there. You can taste the answer. And temperature final is going to equal 20.4 degrees Celsius. I am always amazed at what itty bitty little change the water has. The iron cools way off. The water barely moves because water is awesome, of course. And that's how you solve the final equilibrium temperature when we mix two different substances. Thank you all very, very much, and I hope to see all you clever little cupcakes next time.